All right, so here we go with the Unit 4, Semester 1 review. Going through these problems quickly. I may leave them off if it just gets too nasty with solving some things, just for the sake of time. So on this first limit here, I can't plug in 3 because that would make the denominator equal 0. So I'm going to factor the numerator to be x plus 3 times x minus 3, which cancels out. And so then now I can plug in 3, and I just get 3 plus 3, which is equal to 6. On the second problem, however, I can't factor the numerator because it's x squared plus 9. And this limit right here does not exist because if you approach 3 from the positive side, then you have a positive number. And if you approach 3 from the negative side, then the numerator is positive, but the denominator is negative. And so it doesn't exist because a positive does not equal a negative. In fact, it's actually an asymptote, so it's like positive infinity from one side and negative infinity from the other side. It would look something like this, with this value here being x equals 3. Let me do this. I'm going to zoom in a little bit so we're not wasting so much space. Great. Okay, so then the third one, limit as x approaches infinity. Because they both have x squared in them, then the limit's just going to be 3/5, the ratio of the leading terms. Great. All right, moving on down, finding the derivative from first principle. So this is just a lot of writing. When you do this, you have to do the limit as h approaches 0 of f of x plus h, and minus f of x all over h. And if you do that, you can expand out x plus h cubed like this. And that's just cubing it. If you don't use the shortcut, and the shortcut I'm talking about is thinking of Pascal's triangle, where you have 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. If you want to set it out 3 times and FOIL it, you can do that. Or you can just use the little shortcut. And all that's over h. And all that has a limit as h approaches 0. And then lots of things cancel out. X cubed cancels x cubed. Minus 5 cancels plus 5. Plus x cancels minus x. And every term that's left over has an h in common. So you can factor out an h, leaving you with 3x squared plus 3xh plus h squared plus 1, all divided by h. So now h divided by h is equal to 1. And now you can substitute your limit in for the 3 remaining. Sorry, not for that. You can't plug it in for 1. That's silly. But you can plug it in for the h values there. And so you end up with a final answer of 3x squared plus 1. Great. If you're doing the limit from the derivative from first principles of my second one, you're going to have a couple different tricks that end up happening. So I'll go through this pretty quickly. We have f of x plus h minus f of x over h. Again, doing the limit as h approaches 0. So we're going to do 2 different tricks. When we're looking at the fractions, we want to find a common denominator. So if I have 3 over x plus h minus 3 over x, what I do is I multiply the top and the bottom of this expression by x, and I multiply the top and the bottom of this expression by x plus h. So they now have the same denominator, and the numerator becomes 3x minus 3x minus 3h. So I did 3 times x, 3 times h, and I had a minus sign. So that's why both of those are negatives there. And the denominator is just x times x plus h. With the rational part, I have x plus h plus, not plus, x plus h minus square root of x. And what I'm going to do is multiply that by its conjugate, which means switching that to a plus in the middle. You can't multiply by a conjugate out of the blue, So I'm just going to multiply it by the conjugate divided by itself. And the reason you do that is because if you FOIL it out, you'll end up just canceling the square roots, and the negative root x times x plus h cancels with the positive root x times root x plus h. So you end up with x plus h minus x. All of this, oh, and sorry, over the new denominator. All of this is divided by h. All of this is the limit as h approaches 0. I know I'm going kind of quickly. Please ask me if you want me to spend any more time on any of these problems. 3x cancels 3x. X cancels x. Now h is left over on the top, so I can go h cancels h and h like that. Now I can plug in the limit as x approaches 0, and I have nothing left over here, so it's just 1 over x times x plus 0. And over here, I have nothing left over on the top, so I just get 1 over square root of x plus 0 plus square root of x. So what I end up with is 1 over x squared plus 1 over 2 square root of x. There you go, and that's the correct answer. Okay, moving on down, finding the derivative with respect to x and any critical points. So derivative 3x squared plus 12x plus 8. Critical points, make it equal 0. I don't feel like factoring that, so I'd say quadratic formula, blah, blah, blah. That'll give me two x values, and then I plug in, and you get y equals. So make sure that when it says critical points, and I even gave you another clue here, coordinates, you need to find both the x and the y. I'm going to leave it there for that one. For part B, you're going to do a product rule. You could FOIL it all out if you want to, but I actually suggest doing a product rule. So that's my f prime times g plus my f times g prime. Okay, and if I want that to all equal 0 to find my critical points. Now this looks like a big mess here, but what I notice is that there's some factors that show up in common. Both of the terms have a 2x plus 1 and a 3 minus 2x in them. And in fact, the 3 minus 2x shows up at least to the second power. Now the first term, if I pull out this factor and two of those factors, what I have left over is 2 times 2 times 3 minus 2x. And on the second term, if I pull out one of the 2x plus 1s and two of the 3 minus 2x's, then I have plus 2x plus 1 times 3 times negative 2. So then I can find my critical points by setting each of these factors equal to 0. So this would be x equals negative a half. This would be x equals 3 divided by 2. And this whole business I haven't solved yet. So this is 4 right here. So 4 times 3, 4 times 2x. This is negative 6. So negative 6 times 2x, negative 6 times 1. So I end up with 6 minus 20x equals 0. So x equals 6 over 20, or 3 over 10. So those are my x coordinates of the critical points. And so then I just plug all those in and find the y values. And I'm not going to make you watch me do that. Okay, moving right along. Okay, related rates here because we have a spherical balloon's volume inflating here. So if this is the rate of change of the volume, I can call it dV dt. We actually want the rate of change of the surface area. So if I look at the surface area of a balloon, it's 4 pi r squared if we assume it's a sphere. And that means that the rate of change of the surface area, I do power rule, but then we're thinking of the letter r as a function of time. So we multiply by dr dt. Unfortunately, I know that the r value is given as 9, but I don't know what to do with dr dt. And the question gives me dv dt. So how can dv dt become dr dt? And that's why I like this question, because it requires you to kind of set it up in two different ways and combine those clues together. Well, the question gave me the volume, the rate of change of the volume. So I write down volume, and then I take the derivative of volume. So multiply by 3 and do the chain rule. You might notice that the rate of change of the volume is very similar to the surface area equation, and that is not a coincidence at all. The surface area is what you get if you add on an infinitesimal amount to the radius. Think about it, a sphere, move it out a little bit, you have added a shell that is equal to the surface area. Okay, anyway, my point with doing this is now I have that dv dt is 3, I have that r is 9, and I can solve for dr dt. So dr dt is 3 over 4 pi times 9 squared. And now I can substitute that piece of information right there, and it comes out to some big number or a small number, and you just type it in to your calculator to get it. Okay, last one. If I remember right, this gets a little bit nasty, but we will do it. So if I multiply both sides here by x minus y, then I don't have a fraction anymore, and that's great. And so this should not say, I wrote it wrong, this should say equals right here. I'm asked to find dy dx, so I'll take a derivative. So here's the derivative of the left side. I'm doing the product rule. The derivative of the right side. I'm going to distribute out x squared, and I'm going to distribute out 2x. Then my goal is to get dy dx by itself. So I'm going to move this term over there and move this term over there. Oh, and I'm noticing I have some like terms right there. So 3x squared minus 2xy minus 1 equals dy dx plus x squared dy dx. So common factor of dy dx means I can write it like this, which means I can divide both sides by 1 plus x squared. So my whole left-hand side can be divided by 1 plus x squared, and that's dy dx. I also have to find critical points. So I need to actually take the answer that I have here and set it equal to 0. So there's going to be kind of a lot of algebra here. The first thing I'm going to notice, though, is that if I set this equal to 0, I really just need to find where the numerator equals 0. So we have the numerator equals 3x squared minus 2xy minus 1. And that means that if I add 2xy, I have this. And if I divide by 2x, I have a substitution that I can make for the letter y. If I substitute that into the original equation, then I know that x squared equals x plus y over x minus y. And if I multiply both of them by 2x, I get 2x squared plus 3x squared minus 1 over 2x squared minus 3x squared plus 1. Combining like terms gives me 5x squared minus 1 over negative x squared plus 1. Remember that this is equal to x squared, so I can multiply by the denominator. Let's see if I can squeeze this up here. And if I multiply by the denominator, I have negative x to the fourth plus x squared equals 5x squared minus 1. I'm going to make it equal to 0 and solve it like a quadratic equation. I mean, I guess I could complete the square on it, but I don't think you're less familiar with that. So let's try the quadratic equation idea. Negative 4 plus or minus the square root of b squared minus 4ac all over 2a. So that tells me x squared equals negative 4 plus or minus the square root of 20 over 2. Only one of those answers is true, and that is the plus answer, because your square root will not be equal to a negative number. So that means that I have two potential answers, and those are plus or minus the square root of all that stuff that I just found. Okay? When you plug those in, don't forget, like I've mentioned a couple times in this video, you plug in to find the y value. So again, I know I'm going fast. Please ask if you want more detail about any of those problems. I'm just trying to give you a quick idea of how to go through them.